Hello, welcome to the channel and the video. I am your host, Matt. Thanks for tuning in. As you know by the title, this is 10 things that you begin to notice the more and more you program. And the first thing is, you begin to think more about how machines work, especially automated machines. I was at Kroger today and I went to the automated checkout and I noticed it when you it tells you to place your stuff in the bag and you set it in there and it knows, and if you remove stuff it knows. And I was thinking about it from a programmer's perspective, how it does the weight, and it sounds pretty straightforward. You place something in there, it checks the weight, but there's always going to be little variations, so it's going to have to do things like accommodate for small error. So the more you do programming and the more you think about problem solving, the more you'll realize that these automated machines always have to account for small error and pretty much disregard. Because if the weight suddenly shifts by just a tiny fraction of a pound, it's probably not a big deal, and they don't want to throw an error in that case. Number 2, everything's an algorithm. I always think about this when I'm driving, oddly enough. Nearly every task you do can be broken down into an algorithm. With driving, I always think of staying on the road, basically how you drive to work around traffic. That can all be worked out into some kind of precise algorithm. But also, when you think about something like throwing a ball, you begin to realize how it arcs and how the speed changes, and there's a specific algorithm to that. And it's like that for nearly everything. And the more you get into programming and studying algorithms, the more you start to look at just little everyday things and think, there's a specific mathematical algorithm behind that, and it's just for something that sort of just happens after a while. Probably happens more to like game programmers than other types. And number 3, how difficult artificial intelligence is. I used to think artificial intelligence can't be that hard, just a bunch of if-else statements pretty much, right? I think it's a little more complicated than that. It's a lot more complicated than that. You see, the problem with it is there's just so many cases, and you could never really have every case in the program. It would just take, there's a couple problems and a couple reasons why. You pretty much have to make general cases that cover the majority of things, and they have to be general enough to cover a variety of cases all at once. For example, if you think about let's see, what's a good example? Well, let's go back to cars. The problem of self-driving cars. Most of them just do distance checking and sides of the road checking. Some basic things like that to keep going, and they use data from the GPS and maps to know what the speed limit is. And it's pretty straightforward with just those few things. But they can never really account for every single little thing. Like, do they check for things above the car and think, oh, if something's about to fall on the car, I better move? I don't know, probably not. But AI isn't as simple as it might seem once you begin to think about every little case and the many errors that could happen and how that can affect more cases going forward. It's a little more complicated than that. And I think the better you get at programming, the more you start to see that most games, for example, only use just pathfinding pretty much, and some basic player tracking, and there's really not a whole lot of things behind them. It's pretty difficult to make it really elaborate and make it human-like. Number 4, imposter syndrome is real. I think every developer experiences this pretty heavily, and I thought a lot about it, and there's no real easy way to overcome it. Programming is just kind of hard when you get really into it, and there's always more to learn, and I think that's why it often takes a day or two to solve a problem that you would hope to solve rather quickly. And when that happens, you begin to feel like maybe you're not good enough, that maybe you're not fit for this task. And that's basically imposter syndrome, and you really just got to learn to keep trying and push through, and that's what makes a good developer. If you give into that imposter syndrome, well, then you are an imposter, because, well, maybe you're not, because you admitted that you couldn't do it, so that doesn't make you an imposter anymore. I don't know, there's a weird conundrum there. But it's a real thing that pretty much all developers and all difficult problem solvers face, is they eventually encounter something that's not easy to solve, and they feel like maybe they're not cut out for it. I think it happens to a lot of people in their careers, but it's just a syndrome. You can push past it, and almost everybody can push past it. Just don't give up, and just keep researching. Number 5, why programmers are paid so well. This is something you begin to realize when you've been doing programming for a while. There's so much to learn about programming and so much to know, and it's pretty much just a non-stop thing. There's not very many people who can do it and stick it out long term and really solve the challenges that need to be solved in a big company or in a big program. So that's why developers tend to get paid so much, is, yeah, those two reasons. They're really rare, and there's a lot of competition for the few good ones that are out there. Number 6, you never get a chance to stop learning as a developer. You really don't. You know, I always assumed when I first started to program that eventually I would hit a limit where I kind of know everything and could do everything. But now that I've been doing it for a while and feel like I'm decent enough to accomplish most tasks within a reasonable time, I'm starting to notice that it never ends. It's an endless knowledge hole. And I actually like that, because I tend to get bored of things that get easy. So for me, it's a good thing, but to others, they might feel a little discouraged by that. Don't be discouraged. Just specialize instead is what I would recommend, because you can at least get really good in one area, and you can depend on friends or coworkers or other people for other areas, and there's no way you're going to do everything. It's just not really even possible. So another reason you should specialize. I did a video about that a couple videos back if you want to hear more about why you should specialize. Number, what is this? 1, 2, 3, 4, 5, 6, 7. Number 7. Only other technical people truly understand what you do. I can see this. I always thought programmers were, I don't know, like you see on Grandma's Boy, the guy with the, I can't remember his name. I always thought programmers were like that. They just were in some other world where they're doing something that's not even possible to normal people. But that's not true. And once you start to learn about programming, you start to understand what they do. But until you kind of get into programming, it is very difficult to relate to your work to other people's work, because it's just so different. And that, I don't know what to say about that, but it does seem to be a thing. Number 8, making video games ain't easy. What ends up happening to most people, almost every developer I've talked to, a lot of the kids I went to school with, and even the people in my job now, everyone wants to make a really cool game, but it's not easy. It's quite difficult. You have to have a really advanced knowledge of algorithms and linear algebra, and not only that, you have to learn quite a few libraries to get things integrated correctly. Making simple games is pretty easy, but when you start to try to make big games, especially like, I don't know, like a first-person AAA game, you start to realize how much stuff was involved with the animations and getting all the logic right and the collision and the math and making sure people don't fall through the world and go through walls. It requires a lot of processing power, and you got to do it just right so that it actually can run at 60 frames per second. It's quite a difficult thing. Most people end up getting normal more normal day jobs maintaining things rather than developing games, just because developing games is so hard and it requires so much time. I'm actually aiming to be a game developer in the long run, so I try to take on incredible challenges as often as I can. I'd recommend the same, but it's very brutal and it's not for everybody. Number 9, how much time it takes to build something good. This kind of relates to the game thing, but it does. Usually when you come up with an idea, you can think of a few core things about it that would make it kind of good enough, and once you implement those, you start to see all kinds of other little problems and other little holes and how it could actually be improved to be more usable, and it ends up taking quite a bit of effort and time to make it truly usable. I really like making little tools, and it seems like that's a useful thing, but those are only really good in a little niche environment. So to make something that's truly a great piece of software or a great game, it's going to take a lot of time. The more you program, the more you start to see that. And last but not least, why good design is needed before you start to code. When I was a new developer, I would get an idea and I would jump straight into trying to code it, only to be lost and confused an hour in, thinking, well, where was I going with this? What do I need to do next to make this work right? You start to realize, as you get more experienced, that you really need to have a good design in place, and that will save you a lot of time, because you won't be rethinking in the middle and trying to think of the ideas you had earlier and how you were putting them into place. So that's another thing, is to just get really good at design, and that makes a big difference for coders. I think also that's why you see in most projects you see designers and then you see programmers. It's rarely the programmer that's also the designer, and I think the reason for that is just programmers have to spend so much time just knowing the technology that often when they come up with an idea, they implement it in a very basic tool-like way, but it's often not designed well enough to be truly usable. So you really got to have a good designer in place to keep the programmer on task and doing the right thing. Well, that's all 10 of my things that you start to realize when you become, the more you program. Hope you enjoyed this video. Don't forget to give it a like and subscribe to the channel if you're not already subscribed. I'll see you in the next one. Keep coding.